Okay, so once again, I am not here today. Today we're going to look at direct and inverse variation along with some application problems within the rational unit. Before we get to the notes, you should have taken care of your quiz last class. You should have had that then. If you did not, if you were not here for that, I need to know Monday as soon as possible. Okay, that way we can get set a time for you to make up that quiz, because that is on the third 6 weeks, and you will, if that is not made up before I have to turn in grades, you will have an incomplete for that, which if grades affect any kind of eligibility you may need for extracurricular activity, then that incomplete will affect that eligibility. Just so you know, next class we'll have a review. And then, of course, after your review, that is always followed up by a test. So, getting into today's stuff. First, we're going to talk about direct and inverse variation, which you have talked about this before in Algebra 1, but we all know how that goes and how well our memory is on remembering all of that. So, we're going to quickly go through this, and then we'll go through a few different kind of word problems that I don't think are too difficult. So, first we'll talk about direct variation. In both situations, though, you're going to have a k value, which we're going to call it constant of variation. If something is constant, that means it doesn't change. But whenever it says constant of variation, that means the stuff around it is changing. Whenever you have a direct variation problem, guys, it's just a linear equation, okay? You have that y equals mx plus b format. The k is the slope, essentially, if you want to have something to compare it to. The best example I can give to you, and you'll see one here in a minute, is your wages, or how much you get paid per hour for your job. So if you get paid $8 an hour, then that 8 is the constant of variation. The number of hours you work would be your x, and your y would be the amount that you get on the paycheck. So the basic direct variation equation is that y equals k times x. You need to know how to find k, though, because a lot of times on all these problems, you're going to be given an x and a y that goes together. And then maybe on the next problem, you're going to be given the y, and you're having to find the x. Or maybe vice versa. You're going to be given the x, and you have to find the y. So with the point that you're given, both x and y, that's how you're going to find the k value. So to find the k value on a direct variation, it's just going to be the y value divided by x. And then once you find that k value, you can use this equation, the y equals k times x, and the one value that you know in the other point to find the missing value. So let's go to number 1. It says y varies directly. What I really want you to start doing is highlighting whether it says directly or inversely, which we'll get to those here in a minute. And what I would do above that word is I would put that's for inverse. I would put how I need to find k in those situations. So it says if y varies directly with x, and y equals 28 when x is 7, find x when y is 52. So exactly what I was saying, you're going to be given a point. Okay, we're given 7, 28. We need to find x whenever y is 52. So to find k, I'm going to use the 728. Okay, like I said, k is y divided by x. So 28 divided by 7 is going to tell me that my k value is 4. Whenever you're asked to write an equation for these, they're asking for that form or that form if we're doing inverse. Okay, so if k is 4, the equation they're wanting is y equals 4x. And then to find x now, whenever y is 52, I'm going to put 52 in for y. So 52 equals 4 times x. And then 52 divided by 4 is what is going to give me the x value, which on this that would be 13. Okay, so let's actually jump over to 3. 3 is a word problem that is dealing with direct variation. It varies directly. So again, the way that I'm going to find k is y divided by x. So it says Julio's wages vary directly with the number of hours that he works. If his wages for 5 hours are $29.75, so there's 1 point. Whenever it's a word problem, you're going to have to find these. It's not just, hey, here's x and here's y. So 5, $29.75. Then it says how much will they be? How much will they be for 30 hours? How much will he make for 30 hours? I'm not sure what happened on that problem. So now we're given the point 30, and then we'll have to find the y value that goes with that. Okay, so to find the k, I'm going to take the points from the coordinate that I have. So that's going to be 29.75 divided by 5. So that tells me that k is going to equal 5.95. Again, it asks for the equation, so I'm going to write y equals the k value, which on this one is 5.95 times x. And since it gave me the x value, this one's going to be pretty simple. I'm just going to do 5.95 times 30. And that would tell me that he would get paid $178.50. So there's both just a regular, here's x, here's y, and then also a word problem with direct variation. So going back up to the box where it talks about inverse and direct. So now we've got inverse variation. Okay, y equals k over x. So on these problems, to find the k value, it's going to be x times y. Everything else is going to be set up the same, the kind of problem. You're going to be given both the x and y value of one coordinate, and then you're going to be given either the x and you have to find the y, or you'll be given the y and you have to find the x of another coordinate. So let's jump down to 2. So it says that they vary inversely. So above that word, I'm going to put k equals x times y. And then it says whenever y is 7, x is 4. Find y when x is negative 2. And so on this one, to find the k value, I'm going to multiply the x and the y and the coordinate that I have both x and y on. So 4 times 7 is going to give me 28. It asks me to write the equation, so I'm going to have y equals 28 divided by x. And then now to find y when x is negative 2, I'm going to plug negative 2 in for x, and y equals negative 14. Alright, so coming over here on to problem number 4. So here's a word problem with inverse. So k equals x times y again. It says the diameter of the string of a violin varies inversely with the frequency of its pitch. And so it's actually got the information down here on C. So we'll come down here to find it. So it says if the diameter is 5 millimeters and the pitch is 500, what is the frequency of the pitch when the thickness is 15. Alright, so you'll have to kind of look on your notes, the little doceri icons in the way down here. So to find the value for x, I'm going to take 5 and I'm going to take 500 and multiply those together. That gives me a k value of 2500. It is an inverse variation, so it is going to be the y equals the k value divided by x. And then to find the pitch whenever the string has a diameter of 15 millimeters, I will just do 2500 over 15. And that tells me that it would be 166.67 hertz. So that's just a quick summary of inverse and both direct and inverse variation. If you have any questions over this, you need to come in and get help. This is something that you have already been taught. We're just trying to kind of knock the dust off of it here, because you will see problems like this on your test coming up. So if you go down to the bottom of this page, so some real world problems that you'll see. I kind of give a few of them different names just for the sake of giving the names, really. But it's ways that you can identify it, and it's just going through and reading it is how you're going to be able to identify it. What is the problem talking about? This one specifically, I call 1 over alone, but how you're going to set these up, just to give you somewhat of a formula, it's going to be 1 over alone plus 1 over alone equals 1 over together. But whenever you hear me just say a 1 over alone problem, these are the ones I'm referring to. And what's going to be talking about, it's usually talking about people, but how long it takes one person to do a job, how long it takes another person to do the same job, and then how long it takes for them to do it together is usually what you're trying to find. Sometimes they'll flip it up and you'll have to find how long it takes one of the people to do it, to do that job by themselves. So it's always going to be 1 up here. Okay, do not assume that this is going to be 2 because 1 plus 1 is 2. That's not how it is. Whenever you're setting this up, just think of that as 1 job, 1 job, 1 job. Okay, and it's that same job, and I'll kind of clarify that. A lot of times there's some confusion, and number 2 is a good example of that. But going through this first one, it says Miss Pearl, Miss Harrod want to decorate their new offices. If Miss Pearl decorates the offices alone, it will take her 2 hours. Miss Harrod works alone, it'll take her 4 hours. How long will it take them to finish the time if they work together? So it says, what is the rate that Miss Pearl can decorate the office? And it kind of gives you a little, it gives you this right here. Now, it says rooms, those little in parentheses, those can be confusing with how I teach this, with the 1 always being on top. So even if it is 2 offices, I want you to think is decorating those 2 offices as 1 job. And it says that it takes Miss Pearl 2 hours. It says that it takes Miss Harrod 4 hours. And then on C, it says what is the rate at which they can both decorate the office together. If they do that same job, we don't know how long it's going to take. It doesn't tell us. D asks us to write the equation out. Okay, this is where we're getting into the formula that I gave you up above. So 1 over 2 plus 1 over 4 equals 1 over x. 1 over alone plus 1 over alone equals 1 over together. Next, we need to solve it. So this is adding fractions, which to fill in the gap there, that means I have to find some common denominators. So I'm just going to look at the 2 fractions. Just going to look at the 2 fractions that I'm adding together. So 1 over 2 plus 1 over 4. Okay, the common denominator on that would be 4. So I need to multiply I need to make that 2 a 4, so I'm going to multiply this first fraction by 2 over 2. Hopefully, also you know that it's just kind of taking the fraction and doing the opposite of simplifying it. So I'm going to have 2 over 4 plus 1 over 4 equals 1 over x. I'll add my fractions. That's going to give me 3 over 4 equals 1 over x. Okay. Anytime I have it set up to where it's a fraction equal to a fraction, I can cross multiply. Some of you were taught this by some kind of method called butterfly or something weird like that. If that's how you do it, awesome. But you'll hear me refer to it as cross multiply. So I end up with 3x equals 4. And so it would take them 4/3 or 1 1/3 hour if they were to work together. Alright. Now whenever you're doing these problems, make sure that your answer makes sense. Whenever you see this 1 over ln plus 1 over ln equals 1 over together, it would not make sense that if it takes 2 hours for Miss Pearl to do it and 4 hours for Miss Hara to do it, that it would take 6 hours if they work together. That doesn't make sense. It's going to take less time if they work together. So make sure that whenever you get these answers, a lot of times compare the time that you get with the other 2 times that you're given in the problem. So going through number 2, right here it says Ashley and Lindsay want to start a business painting fences. They figured out that they could paint 200 fence in 40 minutes together. So it's giving you the 1 over together, not the 1 over alone. Okay, so I can come down here to C, where it says what is the rate that they can paint the fence together. It takes them 40 minutes to do it together. Ashley can paint the fence in 70 minutes alone. Okay. And then Lindsay, it does not give this to us. So this is a good example. I was kind of talking about on the first one where this is a good example of something else. A lot of people will see that 200 foot of fence and they'll put 200 as the numerator. I want you to see painting 200 feet of fence. That is the one job this problem is talking about. So use 1 and it's going to make the math a lot easier than if you use 200. So we'll write the equation. We've got Ashley's rate plus Lindsay's rate equals 1 over together. So again, I'm going to look at the 2 fractions that I'm adding together, and the common denominator between those 2 is going to be 70x. Okay. So what that first denominator is missing is x, so I'm going to multiply it by x over x. 1 times x is x. 70 times x is 70x. Plus the second denominator, which is just x. I need to multiply it by 70. Over 70 so that I get that common denominator. Okay, and that is going to equal 1 over 40. So now I can combine these 2. Now obviously x and 70, you can't combine them, so we just write it as x plus 70, and that equals 1 over 40. And then I'll cross multiply. Make sure whenever you cross multiply, I need to multiply both the x and the 70 by 40. Okay, don't just multiply it times the x or times the 70, you're distributing it. So 40 times x is 40x. 40 times 70 is 2800. Equals 70 times x, or 70x times 1 is 70x. Now after that I can subtract the 40x. So 70 minus 40 is going to give me 30x. And then whenever I divide 2800 divided by 30, that's going to give me 93 1/3 minute. So if Lindsay was to paint this fence by herself, it would take her 93 1/3 minutes. Okay, so make sure that you know how to set these up. 1 over alone, plus 1 over alone, plus 1 over together. Make sure the information, you know what information they're giving you. They may be giving you the together time, and you have to find one of the alone. Or it may be like the first one, where it gives us both the alone times, and we have to find them together. Okay, so both of those are examples of the 1 over alones. Going to number 3, this one's a little bit different. I think this one is actually probably a little bit easier than those. So this is what I call these free throw problems, because that is the most common example that you'll see. But really the idea of it, as you read through it, it's going to say that usually sports is it's the most commonly used example for these kind of problems. But a certain person has, for example, made 15 of 20 free throws, and he's trying to get to 90%. So how many free throws in a row must he make to get to that 90%? All right, this can be batting average if it uses baseball. This can be, I think there's some tennis examples that we see. But anything like that where they're at a certain percentage now and they want to know how many in a row they must make, or how many hits in a row they must get in order to get to a certain percentage. Okay, so I kind of already talked about this example right here. He's made 15 of 20 free throws. He needs to have a 90% free throw average to earn a certain bonus. How many must he make? And the key to this is in a row to improve his average to 90%. So A asks, A says his free throw average is calculated by the free throws made over attempted. Now what we're going to find is adding that X, that's going to be able to help us find what he needs in order to get to that. So after that it says what expression would represent the free throw average. So currently he is 15 out of 20. And then we're going to add X to the end of both of those. So after that, we're going to set that equal to 90%, or 90 over 100, and find how many free throws in a row we must make to get to that 90%. Now, one thing that will make your life a lot easier is knowing that if you're dealing with percentages, 90 over 100 is the same as 9 over 10. But you need to know that I can reduce the percentage side. I cannot reduce the statistics side. Okay, so those are his stats. He's made 15 free throws. If you reduce 15 over 20 to 3 over 4, now you're only saying that he made 3 free throws, which he didn't. He made 15 of 20. So you can reduce the percentage side. It makes the math a lot easier. And now I have one fraction equal to another fraction, so I can cross multiply. So I've got 15 times 10, which is 150, plus 10 times x, which is 10x. And then I'll distribute the 9 to the denominator of the other. So I've got 9 times 20, which is 180. And I've got 9 times x, which is 9x. Okay, so then I would just solve. So I could subtract 9x. To get x, I could subtract 150 from 180 to get 30. And so he would need to make 30 consecutive free throws in order to get to that. Okay. Now, to get to 95%, okay, you would do the same thing. I would still take 15 plus x over 20 plus x. And we won't work this one out just for the sake of time. So I could set that equal to 95 over 100. But I just want you to know that if you can reduce that fraction, I would. It's going to make your math a lot easier. Alright, number 4. This is not one of those free throw problems. This is finding the average, setting up to find the average of some kind of item is usually what this talks about. I don't really have a name for these kind of problems, but a lot of this is just setting it up to find the average of the cost of something as time goes on, really. If you talk about, if I spent $20 on something and I only keep it for 1 year, then I spent $20 per year on that. As opposed to if I kept it for 2 years, on average, I spent $10 on that. But these problems that you'll have on here, they get a little bit more confusing than something as simple as that. So it says Remington purchased a new cell phone for $350 and added an annual warranty plan of $35 per year. In what year will Remington's average annual cost of owning the phone be $122.50? So that's what we're finding right there, is the average annual cost of owning something. Okay? And as each year goes by, your average annual cost is going to decrease because you've had it for 1 year longer. So on A, it asks to write the average cost using X as the number of years. So if I'm just going to write the cost, not the annual cost, average annual cost, but just the cost, this thing cost him $350 plus he's putting $35 per year onto this thing. So if he only had it for the first year, then he spent $385 on it. Okay? If he had it for 2 years, 35 times 2 is 70. 350 plus 70 is 420. Okay, so now he's invested $420 into this, but he's had it for 1 more year. So if we're going to find the average annual, then all that means is I'm going to divide by the number of years that he owns it, which it tells us to use as X. So that right there, that's going to be the average cost with X being the number of years. So what this is asking us to do is we're trying to find when is this average annual cost going to equal 122.5. Now, I know that looks like, if it helps you to do cross multiply, you can. Or you can just know that if I'm dividing by X on the left, to get rid of that, I just need to multiply both sides by X. If you want to put 122.5 over 1 and cross multiply, essentially you're just doing the same thing. So we need to figure out, we're trying to figure out how many years would it, for him owning this phone, would it take for that average annual cost to get down to 122.5. So the first thing I'm going to do here is multiply both sides by X. So that is going to cancel X in the denominator of my fraction. Now I'm going to have 122.5x. Once I have that, I will subtract 35x. That's going to give me 87.5x. And then whenever I divide 350 by 87.5. That's going to give me 4. So whenever it says determine what year the average annual cost will be 122.5, that will be after the 4th year. Okay. So we've gone over, hopefully knocked the dust off of direct and inverse variation. We went through a few different kind of rational real-world problems. A lot of the difficulty that people have on these is being able to set up the problem. Going through a word problem and being able to set them up, because they really do, they look different. From the 1-over loan to the free throw to this number 4 that we did here at the end. All of them look different from each other, and it's just being able to read through a word problem and being able to set up that equation. So whenever you get back on Monday, I will be here. That is the plan. We will have a review, which I apologize for being gone for so long, but it's just part of it. We will have a review, which I'm sure there will be plenty of questions, and then on Wednesday and Thursday, you will have your tests. So make sure that you are attempting the questions or the homeworks. All of these videos are going to be put online on the Learning Hub, so if you want to go on there for just a little refresher, you're more than welcome to do so. So have a good weekend, and I will see you on Monday and Tuesday.